Okay, hello everybody. We're going to recap what we learned today. So today what we really talked about, and I'll give you a sketch, really is, what if I have two parabolas on the same graph? They could intersect in 2 points. And that's what we want to find out today, is where two graphs intersect is where they are equal. So how do I do that? Well, I take my two parabolas, and in order to find out where they intersect, I set them equal. So I set them equal to each other, and then in order to solve any quadratic, I need to make it equal to 0. So I thought, okay, I've got x squared plus 3x plus 5 equals my negative x squared plus my 10x minus 1, and I need to solve. So okay, easy way to do that, plus x squared minus 10x minus 10x plus 1 because it leaves 0 over here on the right hand side, and they'll have a 2x squared minus 7x minus 4. Now if it'll factor, it makes it easier than the quadratic form. So I factored it. 2x times x makes it 2x squared, 4 and 1, but if I do my double smiley, I do get my negative 7 there. So then I get my mini equations. 2x plus 1 is one of my mini equations, and x minus 4 is my other mini equations, and I solve. One value is x equals negative 1/2, and the other value is x equals 4. Right, so those are just the x values of the 2 points. Remember, we're probably going to get 2 points of intersection. So those are the x values, negative 1/2 and 4. So to get their corresponding y values, I plug them in. Either equation. I just liked equation 1 because it looked like an easier number. There's no negatives. So I plugged them both into equation 1. So I plugged negative 1/2 in for x into the first equation, and I wound up getting negative 6.5. So that is one of our points. One of our points is negative 1/2, negative 6.5. So then I took the 4, and again I plugged into the first equation. It's the easiest one to plug it into. Plug 4 in for x into both places, and I get y equals 23. So that's my other point. Okay. So then, if I turn the page, and I want to get a visual idea of what happens, I actually graphed them on Desmos, and I got both graphs to look like this. On Desmos, you can go ahead and put it on Desmos, and so I've got my, let's get my, hold on, x squared plus 3x, 3x, subtract 5, and my other equation was negative x squared plus, x squared plus 10x, subtract 1, and what I see is 2 points of intersection. Okay, it looks like that. And I did a trace of it. Looks like that. And then the nice thing about Desmos, I could tap on the point of intersection, and I was right with my math. Tap it again. Nope, I don't want that one. I want that one there. There's my answer I got. That's exactly right. I can tap on that one. So the two answers I got in my math, doing it is exactly that. Okay, so I made a sketch of my graphs. I have my points of intersections. I have my two graphs roughly sketched. And so then, the book asks, what do you notice about the solutions you calculated algebraically and graphically? Well, it's where the two graphs intersect are basically the solution algebraically, okay? Then we talked about there are only 3 possibilities of answers with two parabolas. They could intersect in 2 points, and that's what we just saw in our example, was 2 points, intersection, right? There and there. It is possible for them to only have 1 point. It's possible to just skim and have a tangent point. And it is possible that they don't have any solution at all. They don't intersect, so that would be no solution. Okay, so the homework today, what we did was page 83 and just page 83. That was all. Okay, those two graphs. And that's all we had, 83, and we'll talk about page 84 tomorrow. Okay, all right, that's all I have. And I will see you tomorrow.